Okay. Great.
That always goes up. Questions? Are there? Yes.
Just a lab, submission question. I just have to print out my drafts. Can I submit them by the end of class?
What was the question at the end?
Can I submit my paper, my lab by the end of the class?
Oh, submit it at the end? Yeah. Yeah.
You can also do it online.
In my nice ideal world, by the time lab starts, everybody will be done. It'll be handed in. It'll all be perfect. Tears of joy will stain them all. But
That doesn't happen.
yeah,
People get too panicked when submission day.
I did well up with Tears of Joy once. I can just recreate that again. But that semester that was a semester that was just so incredibly bad.
Yeah, let's say, are you
And
sure
there
they
was
were,
one shiny hoop.
are you
During the
sure,
pandemic.
are you sure they were of joy?
Oh yeah, those were Tears of Joy. Or well, does it count as a tear if it doesn't actually fall?
I think so.
Tears even if they don't fall.
Okay.
There's no
They
other
were
word.
Tears of Joy.
Tearing up joy.
Sorry, think of the good times. All right. Other questions?
That's not a question.
But thank you for sharing. I apologize. I've had people give me the thank you for sharing and just such a dismissive comment.
It's okay. It feels like everyone.
I apologize.
I got it wrong.
All right, so we last left off where we were throwing things off a cliff. So we're bringing out the picture, so I've got 50 meters there. It seems like we got to an answer last time, right? How far from the bottom of the cliff?
No, we just had some of the measurements for.
We got the equation?
velocity.
Yeah.
Well, yeah, we just had.
All right, so let's finish that off then. So we went through, this was negative 50 meters, this is negative 9.8 meters per second squared. This was
Initial velocity was 0 and atmospheric.
So under.
initial velocity.
under
Oh, that's
J
right.
hat, it was 0 meters per second. And under I hat.
This is J hat, I hat, J hat. Obviously, difficulty transitioning from one class to the next. This is what we're trying to find. This was 30 meters per second. This was 0 meters per second. That's what we had.
And, the final under I hat was, 30 meters per second also.
And that's because acceleration is 0.
Yes.
All right, so I feel like we at least got to the point where I said time is what binds the two. It's like the cement in the building foundation. I think that analogy is going to fall apart very quickly. So we need to find time. And so our two options were to find VF first and then find time, so we could avoid using the quadratic formula, or just find time straight up. And did we decide which way we were going? Or we can do both? VF, all right. So which equation do we use to find VF?
Initial plus 2 times acceleration.
The fourth one down there?
Yeah, last one.
So VF squared equals VI squared plus 2A dot delta. I was using S yesterday. So this becomes 30 squared. Oh. We're doing vertical stuff here. 0 plus 2 times negative 9.8 times negative 50. So we end up with 980. I did my math right. And so what is my final speed, vertical speed? Do recognize that 0 for VI, and you gotta be careful about this, but that 0 for VI is because I am plugging in the vertical components. I know that the initial speed is really 30 meters per second, but I'm only plugging in the vertical stuff.
Yes,
31.3. Thank you. All right. So now, what is the final velocity?
31.2.
No.
Is it the average of?
No.
They're not, wait.
That's the final speed. I'm asking for final velocity.
Oh.
Zero.
Going down, so it's negative?
Yes.
31?
And this is the disadvantage of doing it this way, of finding VF first, is you do need to think through and go, wait a second, it's going down, it's negative. Negative 31.3 meters per second. So we now know what VF is. We then find time. Which equation?
Second one?
First one?
Either of them. I think the first is probably simpler, but I heard the second first. So plugging into the second one, I get negative 50 is equal to 0 plus negative 31.3 divided by 2 times time. At 1.8. No, that's wrong. It's 3 point something. It's 3-ish. Three 3.127.
I got 3.194.
194? So you're saying I was wrong?
No.
Yes.
But you are, yes, correct. 3.194 seconds. Sorry to spoil that for you. So we now know the time. It is the time horizontally and vertically. 3.194 seconds. 3.194 seconds. That's the one thing that's guaranteed to be the same for both. At least I had not thought of an exception yet. But when I do, hopefully it's in time for a test. Now, how do we solve for R?
Can we go with the second equation again to solve R?
Good. If you want. And so I have R. Now I'm plugging in the horizontal information, so I ignore the vertical. Once I have time, I now can forget about the vertical at the moment. So R is equal to 30 plus 30 divided by 2 times 3.194. I'll do the first part, that's 30.
95.82 meters.
I got 95.85. 85.
Not 3.5, but 8.5.
Yes.
So once again, are you saying I'm wrong?
Oh, we didn't. So we didn't round.
Margaret's willing to say it. Like, come on.
You could be.
We didn't round the time correctly. It was
Wait, I got
3.95.
All right.
I probably did something.
You know what? If I'm grading a test or quiz, I'm not going to notice.
But
Because
what
I'll
about
have
if
my,
you do?
I'll have my answer and then I'm gonna look at that and go, yeah, close enough. On a lab, that's different. A lab, I'm calculating to see if I get the same thing, but on a test or quiz, yeah. There's been one test where you could have been off by 0.2 and one was done correctly and one wasn't, because I messed up when I set up the problem and it didn't differentiate the numbers enough. So, but other than that, I'm not gonna know this. On a problem like this. Yeah. All right, done. Oh, questions on this before we extend it and then make it look harder?
Would it be negative or would it just stay positive?
We're talking horizontally here.
Yeah.
From the initial horizontal position, did it go in the positive I-hat direction or the negative I-hat direction?
Positive?
Yeah, so it'd be positive. Also, the question was how far from the bottom of the cliff, which is a distance.
So another question was to find the distance. Did we do all this just to find the distance or to understand the whole motion? I mean,
We didn't have to find the final velocity. We could have skipped that.
okay.
But other than that, yeah, the whole thing was to find this. But since we have that final vertical velocity, the question I'm gonna ask you next is, what is the total final velocity? Or as most people would say, what is the final velocity of the ball? And again, it's not zero. I know the ball's gonna hit the ground and stop eventually, in theory.
In theory.
Well, on a board problem, we can make it nice and ideal that the balls are just gonna bounce forever.
Okay.
However, when we talk about it's hitting the ground, what we care about is just before it touches the ground. So what is the final velocity of the ball?
Is that when we take the initial, no, is that when we take the value from J-hat, value from I-hat, and like average them? No.
Is it gonna be in polar form, like?
I didn't specify, so do you wanna put it in polar form?
30 I-cap, minus 31.3 J. I can be.
-3. I would take off 3 points. If that were 10-point problem, I would take off 3 points for that answer. As a side note, the spirit of what you're saying, absolutely right. I gigged you on a neat thing. There's something that I keep trying to emphasize, and I keep taking points off for it. Some students just,
Meters per second.
there we go. Is that what you're gonna say, Abigail? My final velocity in rectangular form, because I have defined my coordinate system, it'd be 30 meters per second I-hat minus 31.3 meters per second J-hat. Let's put it in polar form just for fun. So first thing I'm gonna draw it out, or sketch it out. So I'm going 30 to the right, 31.3 down. How would I find the final speed? Trig is probably a harder way of finding the final speed, but we will need to use trig to find that angle. Yeah. So this is going to be, 37.2685444.
What? I got 43.355.
I also got 43.
Yeah, I don't know what you're thinking.
What?
I was wrong. So that's my final speed. We need to find that angle. Now we're using some trig. Now I can use any of the three major trig functions or whatever's on your calculator. You happen to have all 6 of them on your calculator, more power to you. Or the 6 main ones, there are even more after that. But it's generally recommended use the arctangent because this has additional rounding in it, these have less rounding in it. So theta is going to be the arctangent of 31.3 over 30, the opposite of the adjacent.
46.21.
46.21.
Yeah. Is it degrees?
You're supposed to tell me. Progress is not a yes.
Degree.
You just trusted her?
Yeah.
Okay. Congrats.
Thank you.
So, in polar form, it is 43.355 meters per second. And what is the angle?
46.21 degrees.
You said 1-1?
Yeah.
I wrote down 2-1 before. Is it 1-1 or
2-1.
2-1? Okay. No, that's not the right angle.
I got, oh wait.
Is it 9? Is it 43.79 then?
Nope.
Negative 46.21 degrees,
Yes.
because it goes backwards.
It's going down. 46.21 degree angles like that. The ball is not going in that direction right before it hits.
That's the answer.
But shouldn't the magnitude itself be negative and not the angle? I mean, like
The magnitude should be a positive number. Thus, when you represent magnitude, you put absolute value symbols around it. It's, you could make an argument that if you want to put negative here, then the angle would be in that direction. So you would add 180 degrees to that angle.
So,
But traditionally, the magnitude is always a positive number, and then this is where you adjust positive or negative directions.
so the final velocity when we were solving this was negative 31.3, but then we were.
That was the vertical component. That was just the vertical.
And then that one is just like the angle component of it. Like if you just went straight down. Is that
I think I interrupted you and lost your question. Ask it again.
so? Like the negative 31.3. So it's the one that's going upward, and then.
What's
I don't know the question.
going down at that point?
Yeah.
When this ball is thrown, and there are much better drawings elsewhere than what I'm about to do. It starts out completely like that. That is, at some moment later, the horizontal component stays the same, but now there is a small little vertical component. A little bit of time later, there's the horizontal component, it should still be the same length, but the vertical component is a little bit longer. And then the horizontal component stays the same, the vertical component is even longer. And so, as it goes, the horizontal component stays the same, and that's still supposed to be the same length as all those, and the vertical component is here. So at this point, that's 30, this is 31.3. But it starts out at 30 and 0. And so what we did before was just find that component. Did it address what you were asking?
Somewhat.
All right, do you want to ask again?
I'll just look it up later.
Or
When we're, is there a way to denote specifically, like, do we need to denote specifically that, like, we're looking for the velocity final of I hat and J hat together? Or is it okay for us to just write it like that?
to write it like this?
Like that, so like, up there we're looking for velocity final, but we're looking specifically on J hat, so when we're looking for like overall, altogether, can we just leave it as,
If I don't specify,
okay,
then like this.
okay.
Margaret, then Rika.
Okay, I might be stupid. Why are you, is it arctangent? Because, like, why is it not just tangent? Because it's like,
You find tangents of angles,
okay,
but if I'm trying to find the angle itself, you use the arc functions.
wait, can you say it again?
So you find the tangent of an angle, cosine of an angle, sine of an angle. So that is, you know the angle, you do the normal trig function.
Right.
If you're trying to find the angle, you have to do the inverse function. So if you're trying to find the angle, that's when you use arctan or arc cosine or arc sine. We're trying to find the angle, we don't know it.
Okay,
If I know the angle, then I can use sine, cosine, or tangent. If I don't know the angle.
oh,
it's
it's fine,
arc.
you mean the side. The length of the
Yeah, if
side.
you're trying to find the side, you'll use either
Right.
Pythagorean theorem or tan, cosine, sine,
Okay,
assuming you know the angle. Yes, Pratika.
You said we could find it without finding the final velocity.
Yes,
How could we have done that?
I'm glad you asked.
If we plugged into the third equation, I have negative 50 is equal to 0t plus 1/2 negative 9.8 t squared. And so basically plugging into the third equation over there and just solving for time. That obviously goes away. And I'm left with t squared is equal to negative 50 divided by negative 4.9. And I think, if I'm recalling, if I can do the math correctly in my head, this is about 3.194 seconds. It better be.
Yeah.
If you made a mistake and you had this as positive 50 and that is negative 9.8, you would have gotten a negative under the radical. And then you'd have to ask yourself, did I make a mistake, or is it possible that this problem cannot exist? If I throw a ball off the cliff, is it possible that it's not gonna hit the ground without some hand of God? Which we all know is Maradona hitting the ball with his hand.